We are in section 6.2 and we are factoring trinomials. Now these are trinomials that begin with a leading coefficient of 1. So the first thing you're going to do is enter x as the first term in each of the parentheses, list the pairs of factors of the constant, try those combinations to get the middle term, and you can check it by FOILing. The other hints that are super important are if the constant is positive, the signs will be the same, and if the constant is negative, the signs will be different. Our first example says factor completely, and it's x squared minus 5x minus 24. Since it ends with a negative, that means the signs in parentheses are different. Okay, so to work this one, we're going to open our parentheses. And I know an x times x makes up x squared, so we'll put x's in the front. My factors of 24 are 24 times 1, 12 times 2, 3 times 8, and 4 times 6. From that group of factors, I'm looking for the group that subtracts to give me 5. So that's going to be 8 and 3. So I'm going to put in there an 8 and a 3. But remember, my signs are different. One's positive and one's negative. So we have to come up with an 8 and a 3 that to combine in order to get a minus 5. And the way that that would work is if the 8 was negative because it's larger and the 3 was positive. So I need the 8 to be negative and the 3 positive, and that would be my answer. Looking at the second one, I know the second problem is x squared plus 13x plus 36, and I want to factor it. Since it ends with a positive, that means the signs in parentheses are the same. I can open my parentheses, and the term that makes x squared would be x times x. My factors of 36 are 1 and 36, 2 times 18, 3 times 12, 4 times 9, and 6 and 6. Since it ends with a positive, I'm looking for my group that adds to give me 13. So this group of factors over here that add to give me 13 would be 4 times 9. And it doesn't matter if you put the 4 first or the 9 first. I know the signs are the same, and since I'm trying to get, I have a 4 and a 9, and I'm trying to get a positive 13, the only way I'd get a positive 13 is if they were both the same. So I'd have a positive 4 and a positive 9. Again, your answer would be correct if you have x plus 9 times x plus 4, or if your x plus 4 happened to be in the beginning. Looking at the third one on this page, x squared minus 2x minus 8, it ends with a negative, which means my signs are different. To make up an x squared, I'm going to use x times x. My factors of 8 are 8 and 1 and 4 and 2. So from that group, 8 and 1, or 4 and 2, I'm looking for the ones that subtract to give me 2. So that would be 4 and 2. My signs are different, so I actually ran out of room, sorry. I have a 4 and a 2, and I'm trying to get a negative 2 out of that, which means my larger group needs to be negative. So the 4 needs to be negative and the 2 positive. So the 4 needs to be negative and the 2 positive. Okay, let's try some others. My next problem is y squared minus 8y plus 15. So we'll go through a little faster through these. The term that makes y squared is y times y. And if I'm looking at my factors of 15, they're 1 and 15 and 3 and 5. The group that would add, since it ends with a positive, you're looking for what adds to give me 8. And the numbers that add to give me 8 would be 3 and 5. I know that the signs in parentheses are the same, And since I'm looking for a minus 8, I know that a negative 3 and a negative 5 would give me a minus 8. So both of these need to be negative. Okay, looking at our next one, it's x squared plus 3x minus 28. The factors that make x squared are x times x, and my factors of 28 are 1 times 28, 2 times 14, and 4 times 7. The group that subtracts to give me 3 would be 4 times 7. So I've got a 7 and I've got a 4, and I'm looking to get a positive 3 out of that. So the way I put my signs would be the 7 needs to be positive since it's bigger, and the 4 needs to be negative, and that would give me an overall result that's positive. So we'd have a positive 7 and a negative 4. My next one is x squared minus 13x plus 40. My factors of x squared would be x times x, and my factors of 40 are 1 and 40, 2 and 20, 4 and 10, and 5 and 8. Of this group, I'm looking to see what adds to give me 13. Well, the group that adds to give me 13 would be 5 times 8. Now I'm actually looking for a negative 13. Remember, if it ends with a positive, positive means same signs, so they're either both positive or both negative. And since there's a negative 13 right here, it's going to be a negative 5 and a negative 8. Checking it out, I know a negative 5 and a negative 8 would give me a negative 13, so that was a good fit. The next one I have is x squared minus 10x plus 21. X squared is made up of x times x, and my factors of 21 are 1 times 21 and 3 times 7. The group that adds to give me 10 would be 3 times 7. Since it ends with a positive, that of course means they're the same sign. And since they both have the same sign, this first one tells you that they're both negative. Of course, if your x minus 7 was written in the front, that's just fine. The last one of these that we have is x squared plus 5x equals 9. My factors of x squared are x times x, and my factors of 9 are 1 times 9 and 3 times 3. I'm looking for the group that adds to give me 5. 9 plus 1 would add to give me 10, so that one doesn't work. 3 plus 3 would add to give me 6, so that one doesn't work. So there is not a combination of 9 that would add to give me 5. So what that means is that this one is prime, it's unfactorable.